Okay. So I noticed that some of you get some errors regarding the assignment. Okay. So I want to direct you to the R tutorials page. Have you had difficulty with the R tutorials page regarding sections regarding downloading material? Yeah, I'm not sure about that particular error message. There seems to be quite a variety of error messages that either is probably a result of your operating system, your software, and maybe the packages themselves. I'm not certain though. Okay. I'll look at the installation of the packages, but let me walk you through that first step. I think this thing is important for the class. So let's start there. When I began, I just want to be sure that am I sharing the screen? Can you see? I don't think you can see my. It looks like I'm sharing my desktop. Let's share my. I'm gonna try to share my web browser. So let me start with that. Let's start with Canvas. I'll just go to the Canvas homepage, and I'm going to share that actually. New share, and I'll share my Firefox webpage. And let's go to the course, and we'll just go to the class webpage. If you could, please mute your video camera, just to make sure that, unless you have something to say. Otherwise, if you have any particular questions, I will invite you to ask me on a one-to-one basis. So let's go to, well, I guess the first week where we talk about categorical data. We'll focus on that issue. So if we look at the assignments, I'll just walk you through downloading the data set and uploading it in R. So first you go through the assignments, and then of course you go to preview. And we have some basic statistical questions, but I'm going to take us down to this data set. If you go down to part 2, R data analysis in R, which is with 10 points, we want you to download. So I'll just open this in a new tab, the data file, and I'm going to open with R. That's typically the default if you actually install R. And then I'm going to let you apply the accompanying code. But in fact, I'm actually going to do something else. I'm not going to open the data set. I'm just going to save it. So let's just save the link as, and I'm going to save it to my desktop. This is what I call data hygiene. I just go to my desktop, and then I'm just going to create a new folder. I recommend you do that yourself as well. So here on my machine, I'll just call this pset, P-S-E-T-1. And this is problem set 1. So I'll just save this R data file. If you see that the suffix of my data set is actually .r data. And I'm going to save the script as well. Okay. So both of those are saved, should be saved to my desktop. And let's just do, I see that I'm sharing my web page. But I'm going to do and stop that share. And I'm going to share my full desktop. So I'm going to share, yeah, you should be able to see my desktop of my computer. If not, please let me know. But if I do that, then you should be able to see that here I have a folder called pset1. And on that folder, I have the Titanic data set. It looks like I did not download my script. So let's just do that. So here's, what's that?
We're viewing your face right now, not your screen.
Okay, thank you so much. I should be able to share part of my screen. Let's just make sure I can do that. Share screen. That's interesting. Huh. You don't see any kind of screen share at all? You're gonna see any of my desktop, is that right, James?
We can see a blue screen now.
Okay, good. Good. Okay, so you should be able to see my full desktop. You should see a Dropbox folder here, my hard drive. And what is noticeable, which I mentioned earlier, is the problem set 1. Now in this folder, you should see 2 files. I'm just gonna simplify the screen here. You should see the problem set 1.r file, and you should see the Titanic.R data file. Those are the 2 sources of data that are basically, those are the 2 downloads you should have for every assignment. And what I'm trying to show you is basically the simplest way to, first of all, download your data set. And this is what R will provide for you, which is called an R data file. Now, if you notice the way that the data file is presented, it is presented as it's case sensitive in the sense that what R identifies or reads in as a particular data file or as a named file, it means that what is capital and lowercase is different if you spell something capital or lowercase. So here in this case, capital T, Titanic, is different than if you just typed in the capital lowercase t for the Titanic data set. You could actually say this is a different file. But the point that's relevant here is that for every week, you're going to have the same two files that you're going to need to download from the class webpage. One is an R data file, and that's a capital R, a capital D, lowercase a, t, a file, and that's the data set you're going to use. That's the information. Then you have what is just a .r file. This is the script or the code. The way I liken this, if you're not into computer programming or that kind of stuff, is that an R data file are the ingredients that you use to basically make your recipe, to use a culinary analogy. The .r file is the actual recipe itself. It tells your computer what to do with the data you have at hand. Now keep in mind, this is assuming that you've installed R, base R, you've installed RStudio, and then you've installed the Mosaic library. Now, you should be able to go to the course website and go to the R tutorials section of the website and be able to download all of that information. If you can't, then please let me know. But that should be working, and it should be uploading to the data set, to the website. So let's begin. Let's just start with the R data file right here. It looks like it wants to open in R right now. Now, there's a difference between R and what is called RStudio, which is considered a wrapper or sort of a kind of a nicer version of R. So I'm going to show you where RStudio is. And this is what RStudio looks like. If I have it saved on my toolbar here, but let's just open it right here. And the first thing I'll do is I'll just navigate to, yeah, I should not save this. This looks like a different file that I had opened at an earlier time. This is what the RStudio environment looks like. It should be pretty intuitive. In fact, I'll just share the RStudio screen just so you could sort of simplify what I'm showing to you. Basically, you have 4 panels here. And this is kind of what's expected when we open up R. The lower right-hand corner, you'll have these different tabs. The Files tab is essentially, if I go to my desktop, you'll see that I have problem set 1 here. This is the one that I'm looking for. And these are the files I want to open. So I can highlight these. I can click on these. And I should be able to open them with it. Or I can just even double-click these. And it asks if I want to upload this file. Yes. So what did I do here? On the Files tab, I just highlighted the files and I uploaded them that way. Essentially, Files just specifies to you where your files are. You can locate them, you can create new folders, you can delete them, you can rename them, you can do other things. Just sort of a like Finder in Microsoft Word, or sorry, not Microsoft, in your Macintosh operating system. Or it's just sort of like your quick search file under Windows 7, for example. Plots is where when RStudio tells your computer or tells your script to upload and create new plots, this is where you're going to see those appear. Packages are important because packages are what we upload after we install R and RStudio. Then we install these packages. And we go here and we install the Mosaic package. And if I type in Mosaic, we can see that I need to actually install this package. Now I want to give this idea to you that I can do it either through the drop-down menu, just as I do with the files. I can do that with the packages. I can install packages. But I can also do this with the command interface. The fourth tab in the right-hand corner is the help file. And we'll talk about that later. I have a video that I'm going to post to the course website that basically is essentially where you need help. How do you find help? And then the viewer, which is just another way to look at the data. But the most important point that I want to make here is that the Files tab is best served if you have one folder. And here you can see I put it on my desktop. I have Dropbox here and I have some other files. But the point is that I have in one folder problem set 1, and under problem set 1 I have an .r script file and a Titanic.R data file. And each week we're going to have a different data file. And each week we're going to have a different problem set file. Typically we do pset 1, pset 2, pset 3, pset 4, all the way through pset 10 or so for the class. What's that? Does anyone have any questions? I'm sorry, I can't hear you. If you could type in the question, I probably could hear you a little bit better, if you don't mind. Yeah. Yeah. Okay, I'll make sure you guys mute if I'm hearing some background noise. That's okay, but just want to make sure that everyone we're muting the background noise. So let's start off with, let me show you another way to load the data file. Here the first thing I did was I kind of gave you a quick tour of the RStudio environment. And I basically distinguished between the scripts and the data set. Another way to upload a file is simply go to, if I click on, I can do a quick sort of a command open, I guess, command plus O shortcut. And then I can open files and I go to my desktop. I can navigate to my desktop and then here I see Titanic 1. I can open my file that way. The main point that I want to make is that typically when you use RStudio, you'll see some untitled file. You don't need to do that or deal with that. But then you'll typically, what you should have is you should have the script for the first file, or for the first problem set. And what I want to walk you through is essentially what the anatomy of a script is. What are we doing here? And the relevant points to make are that you can see essentially the script's broken down into 1, 2, 3 components. The first component is everything in green. Now you might have it in something else, but the stuff in green is not part of the recipe. It actually it's not relevant to your code. These are actually comments that are provided that tell you how to, in essence, as we say, run analyses that you need for the problem set after you've uploaded the problem set. Now the relevant point to make is that you have to make sure that these comments are in green, because if they're in green, they're essentially deactivated. They are not part of the actual process of creating the script. They're not part of the homework, you could sort of say. The other point I need to make is that you will see some that are in blue, and that essentially means that maybe you have a particular function going through, or a particular script that is, a particular command. But most of the time, you'll see that most of the script or the code is in black text or something other than green. And this is the stuff that you need to pay attention to, because this is the code that tells your script what to do. And in this case, before we begin, I want to start off with, reminding you that you need to upload the data file. And here I include this command here. I have at my desktop, and I created a folder called problem set 1. We verified that we have this data set here, and then I use this load function. In fact, I'm going to type this load function right here. I just copy and paste that from my console. This is the console right here. And then I place it right here in the script. I'm going to save that script. I just did a Command S shortcut. And if I do that, and then I run that script, so let's just run that. I just loaded the data file into memory. And I know this for a couple reasons. But the most important one is if I go to my history, I can see it actually. But let's look at that one more time. The main point is that you can upload in 3 ways. You can use the text here. You can navigate to where the file is located, and you can just highlight it right here, and then you can just click it once, and it'll ask, do you want to load this data file into the global environment? That essentially means, do you want to bring it into what it is you're doing right now? And then the third way is using the drop-down menu. You can file, or you can do open file right here, and you should be able to see this in the desktop. So those are 3 ways to open the data file, and that is under the R tutorials portion of the web page. You should be able to see how to open your first .r data file. After that, if you are at this portion of the web page, a portion of the analysis, if you have, that is to say, your desktop folder as pset1, if you have an R script and an R data file in that folder, and if you have the script uploaded in the upper left-hand corner, just as that you've seen right now, then you're all good to go. In that sense, all you really have to do for the remainder of the course is run the script as it is identified. But you have to make sure that you have, first of all, the right script and the data file loaded. Otherwise, you're going to run into these error problems. The error problems often arise when you don't have the data file loaded. And in fact, some of you might just use data, I think, Titanic. I want to show you sort of a way to upload data that are not correct. In fact, you've noticed I just typed a command there. Well, this isn't the data set we want because there's actually 2 versions of the Titanic. There are 2 versions of the Titanic data set. The first version of the Titanic data set we want you to ignore because it is built in to the R environment. In other words, it's just something that is a smaller version of the data set, but it does not include the variables that are of interest. It does not provide the information that we want. So be sure you do not load that up. And in fact, that's what I just showed for you right now. The second version of the data set is the one, in fact, that I've just been showing through class for you, which is this data set that I've downloaded from the course webpage. I saved to the desktop folder, and then I saved within the same folder as our script. And this is the Titanic.R data file. Now, I want us to, I'll sort of show you how, why you might actually download the wrong data file. It's because of this package right here. This is called the datasets package. And in fact, this includes a lot of data that are, as I said, built into the R environment as examples, because often when we're talking about statistics, we want to provide you with examples. Some of these are built into the R data sets. Well, look at this. Built into the R environment is a Titanic data set, and it's the same version as this very famous data set, except, as I mentioned before, it does not provide as much detail. And you can often click on that, and you'll see that it includes a few variables, like class and sex and age, but doesn't provide any of the other information, such as the names of the people in the data set. So this actual data set that I just uploaded using this data function is not the correct one. But it is pretty relevant, and I'm just pointing you in some ways how maybe making a mistake can actually lead to ideas. You can actually maybe even think of a research project that you want to use applying some of the data sets here. But this is a good way to explore R, is if you look at some of these tabulations right here and look at some of these examples. But that's only for this week, I have to say. That's my caveat. But with the rest of the data sets, we actually have substantially different names and substantially different sources that I don't think there should be any source of confusion. Keep in mind, though, that you do want to make sure that for this week that you're downloading your data set correctly. So let's run the script here. I'm just going to click the run button. And we've just loaded the data set right here. And let's, after pointing to you how to load the data set, let me tell you 2 other functions that are crucially important. And these should be run every time you run analyses, I would say. The first is to install the Mosaic package. Now, I've said before, and you'll see in the R tutorials portion of the web page, if you can access YouTube, you should be okay. That you essentially can install the Mosaic package, and you should have to do this once. And here I'm going to do it, I think, probably several times. But you notice that there's typically text in red. You should only have to do this once, and it'll tell you where it downloads these packages. It'll say it installs other ones. These are called dependencies. A dependency is actually, this is other bits of information that the computer needs to carry out its mission, I guess you could say. But the relevant point to make here is that you should only have to install the package, use the install packages function once. That being said, it's no big cost to install your packages again. In fact, I would do them each week, just to be sure, especially if you're using like a friend's computer or a family member's computer. So I just want to show that I can highlight the text. I can just click the run button, and I'm running the script here. And here I'm doing it again. Okay, it was a little bit shorter the second time because it doesn't really matter. In fact, I could just install the third time. That being said, you don't have to do this every time you open R. What you do have to do every time you open R is tell R that you're interested in using this package, because I could use a lot of other packages here. In fact, if I go to the Packages tab, you can see that I have a lot of packages installed, and you might have quite a few installed as well, in large part because these are packages that are dependent upon Mosaic itself. And you'll see that, in fact, these aren't all the packages. These are just the ones that mention data. You'll see that I have quite a few packages installed already. But the main point I want to make is that you want to make sure that you load this into memory. And you just can highlight the relevant text, click run, and you're just going to load the relevant packages. And after you do that, in other words, if you load and install the packages, in other words, just highlight this script, and then I just click the run button, or you can, if you just let your cursor sit on the run button, you should be able to see that a suggested sort of alternative keyboard shortcut is also highlighted. You just click run, and it's going to update those packages. It'll restart the R session here. You'll see that we should be all ready to go. And let me run this script as well to load the Titanic data set. And the first thing we do then is I'm going to show you two commands, two functions that tell you to explore this data set. And the first one is the view function. What are the variables in the data set? Or data frame. You'll often see R referred to as a data frame in the text and the course assignments. So let's do a command view. You'll see that the R data frame for Titanic does in fact have different variables than we had for within the R environment that was built in. And what's relevant is you don't have just whether or not they were a child, you also have their fare, and you also have their name. And this is relevant because the nice point about the view function, and notice that, by the way, I start off with this section saying that everything is case sensitive. Same with the functions. So the typical anatomy of a function is that you have the command, then you have something typed in parenthesis, and then you have that closed parenthesis bracket. And what's in parentheses is typically the data set or data frame that you're manipulating. Here, we just want to view the data frame, Titanic data frame. So let's view that. I just click run, and you see that I'm opening this tab right here. Now, I want to tell you a little bit about what a data frame is, because here we have a view of that. And what's useful within the R environment, or RStudio, I'm hearing a little bit of background noise. If you could mute, that would be great. But if you have any questions, feel free to type that in the group chat. What's relevant here is that you have different kinds of data files. In fact, you can actually see what kinds of variables these are in your data frame, because you can see that several of them are categorical, but not all of them. In fact, we can see gender as a categorical or factor variable with two levels. What are the two levels when you have gender or sex? You have male and female. That takes on two values. You have age, which is in our case is not a categorical variable. It could be adult and child. And in our case, it's a numerical variable that takes on these values in our data frame. Then we also have a name, which is considered a factor variable, but you could also call it a string variable or sort of a text variable, because there aren't any real categories here. In fact, there are 1,307 levels, probably unique, we could say, in this data set. We're not 100% certain, but we'll talk about that later. But it looks like that there are different, each row has its own label for a person's name. Now, social class, it looks like it has 3 levels: lower, middle, and what you can't see is upper. And that takes on 3 different values, 1 or 2 or 3. Then whether or not they survive, that's also a factor or categorical variable. Do they survive, yes or no? And intuitively, you can look at this right here. I'd miss fair, by the way. NUM means numerical or non-categorical. So I just want to illustrate that you can basically look at your environment and see your data set loaded into that environment. But you can also use the view function to see the variables listed. And what's nice about the view function is that you can use this filter and you can subset. Or I can click the filter function. I can just order from lowest to greatest, for example, on a particular value. I can also order by survive, for instance. So here I did, first I clicked age to order from least to smallest to largest, and then clicked on survive, starting with no to yes. And so this is a great way to subset data, especially if you're very familiar with something like Excel. If I want to click this other button right here that I'm highlighting, scrolling over, you can actually open in a new window your Excel file. Using the filter function, you can open or filter subset to a particular sample or particular name. So if I wanted to look at, say, an age, I could actually subset to adults. So this would be like 18 to 80. And here I subset to age. I should be able to order this, yep. So it includes 18 to the eldest person. If I want to subset to those who did not survive, for instance, these are all the people the adults who did not survive. Then here I have a different subset of the data. So that's kind of a nifty way to deal with the data set that I think is intuitive, especially when you're starting out. That's a great question. So some people are asking, well, is there a way to save filter data? Yes, certainly there's always a way to save anything that you define. So you can typically go to, well, I'm not sure how to do it at this moment, but typically you should be able to go to File and then save your file after you manipulate it, but not 100% certain at this moment, offhand, but I will address that. But I think the view function is going to be relatively intuitive for you. So if you're sort of new to the programming environment, it's not something that's you're really comfortable with, I'd say start off with this view command. It doesn't matter whether it's in the script for future assignments. I think it's something I recommend in future assignments regardless. I'd also recommend the names function. So the names function, again, I highlight the script here. This is your R script that we just gave you. And you're going to click run here. And what you often do when you work within RStudio is you will run some script, and that's in the upper left-hand corner. And then it will appear in your console, which is in the lower left-hand corner. And in this case, what does the names function do? Well, it provides us with something that's pretty useful, which is just a list of the names of the variables in our data set. Now, a data set in R is, okay, yeah. So I think that's right. So someone had pointed to the class, to the section comments that when you use the view function, you're actually not able to manipulate it. That probably makes sense. What I'm going to show to you later on is when you do subsets, you can actually do what is called object assignments. So if you were into programming, you might want to look into this. But I could do like names Titanic, and then I just do the assignments, which is operator, which is just sort of a caret, a dash, and then this should be names Titanic. And you notice I have these list of names here. Often what you can do is you can do something that's called the assignments operator, and that's what this is right here. You're saying, I'm taking the names of the Titanic data sets, and I'm just going to call something else, and it should pop up in your upper right-hand corner for your environment right here. So let's run that. In fact, here you see it now. So that might be something to look at as well. If you want a subset, you might be able to do it that way. And if we view the names Titanic data set, you'll see that, what did we create? Well, we just created a vector or a list of the characters of the data, of the names in the data set. So I would point you to using the assignment operator here if you're interested in knowing the subsets of the names. Otherwise, that's something we'll have to revisit later. But right now, I'm going to put this little hashtag in front of the script. And whenever you put a hashtag in front of the script, you're actually commenting it out or saying, okay, I want to make it part of the comments. I don't want to actually run it as scripts. And so that's something important to keep in mind. So that takes us to, I think, the meat of the assignments, which is getting familiar with the R script and then running that script for the purposes of completing the homework assignments. At this point, you should be able to run all of the scripts all the way down to the bottom. So if we go to line 31 in my case, although it's changed because I altered some of the script, I added a few lines, might be a little different in yours. If you go to point number 11, you should be able to highlight that script and go all the way down to the end of the R code and run that. I'm not going to do that right now because I want to illustrate for you, for pedagogical purposes, what's the meaning of some of these scripts. One of the questions that we have that we start off with is approximately how many people in the Titanic were in the lower class. Well, just run that script here. It says it can't find the function bar graph. Well, what's going on here? Looks like maybe, let's try the tally function first of all. Oh, it's not using the tally function. So what it means though, is it looks like we're not having fully installed the Mosaic package. So and that's exactly right. So let's rerun this package function and make sure we loaded that. And you notice when I click the script here, or highlighted the script and clicked run, it actually highlighted, or it actually selected these packages. So there are two different ways to actually load packages. You could you could highlight the script, which is far easier, or you could just click on this. But this is a relevant point, which is make sure that if you're running into an error, typically what I did right here is I just pretty much knew that I didn't load the packages correctly. And if we go back to our starting points, to point number 11, now you'll see that there's no error message. You see actually a bar chart, as you should have seen earlier. Now, what is a bar graph in this case? Well, it's simply a count of the number of people in each class, right? So what do they say in French? Ça plus change, ça plus la même chose. The more things change, the more things stay the same. Well, what happens? Well, is class associated with survival? Well, in this case, it really looks like if you're in the lower class, there are going to be a lot more people in the lower class who belong in the lower class or who were assigned to lower class than are in the middle and the upper classes. But this doesn't tell us about survival yet. But it does tell us how many people were in the lower class, about 500. Now, the difference between a graph, a visualization of data, and the actual stat is that a visualization gives us a better idea of the distribution. We can use what is often referred to as interocular evidence because it's far easier to look at the data, see what they look like. You can see that the lower class is far more prevalent in this data set. But we don't have the exact number. So if you want precision, then you can basically use the tally function here. And here I highlighted the script and I show that actually what looks like 500, in fact, is 500. So how many people are in the lower class? Not approximately 500, exactly 500. And approximately 500 in both the upper and middle class. So that's one thing to keep in mind. That gives us an idea of who's in the lower, upper, and middle classes, but doesn't give us an idea of how survival is dependent on things like social class. So I'm going to actually skip to 13 because the script and the logic is the same as script 12, because here we talk about social class as well as survival. And if we look at social class and survival, we can actually look at, well, we look at proportions. Let's do a bar chart of survival and social class. That's not working. Okay, never mind. And I don't want to save that current plot. In fact, instead what I'll show you is, we'll just walk sequentially through each one because we have a little bit of time. I push us through the earlier parts of the assignment. The first part I want to show that, whoops, sorry. The first part is that when you do a tabulation in R, you can basically look at the Mosaic functions as sort of a shortcut for doing data analysis. But everything you do is after the tilde right here. Essentially, the tilde typically will give you the variable, and then you'll typically specify the data set. And within each function, each argument or subcomponent of that function is separated by commas. In this case, you have the data.
Screen froze. I think the screen froze.
Hello, this is Nathan. Are you still here? You guys still see the section? No. You guys should still be able to see me. If not, just let me know. It looks like I had an issue with internet connection. But now it should not be a problem. Good. Okay. Sorry, guys. Are there any questions so far since I sort of bungled this? Thank you for Christopher for sending that message earlier. I really appreciate you telling me about that. So, you guys have any questions about the content we reviewed thus far? Okay, so that's a great question. Feng Sun had asked this. What is this little squiggly sign if we look at the script? So let me open that one more time. If you don't see the actual, I think you're just seeing my image here, my face here. So I'll reopen the script. I'm going to reopen RStudio. Let me open that and just share the RStudio environment. What does that little squiggly sign mean? It's called a tilde, T-I-L-D-A. That's how you say it, tilde. And what that does is, I'm sorry to interrupt, but I hear a little bit of background sounds. I think it's just someone's family. If you could just be sure just to mute that. I'm not sure if you want to have that recorded for posterity. But just to let you know, that is a tilde sign. So let me reopen RStudio and I'll share that to you. So I'll share my RStudio screen. We should be back in progress. Thank you. So I'm going to go a few minutes over. I'll go about 15, 20 minutes over because I realized we had lost internet connection. Thank you everyone for staying on board. I appreciate your commitment. So I will, we should actually see the RStudio screen as we had basically ended it. And someone had asked, what does this little tilde mean? Well, there are two different things, but the main point is that most of the time when we use the tilde, we're actually referring to everything after, to the right of the command is essentially what we're looking at as the output. So what good way to interpret the tilde as part of the function is to say, what I'm interested in getting in this analysis is something that is a result of, and this is the tilde. And then everything to the right of the tilde is everything that you put as components or ingredients to the outcome that you want. So what you're saying is, what I want is a bar graph that is a result of, and then to the right of that tilde, you're gonna have gender, and you just wanna have the data set Titanic. That's all that you're doing here. So the tilde takes on more importance when you use something called regression or something where the outcome is order is relevant. So we do something called multiple or even simple linear regression. We'll have often refer to what is commonly referred to as a Y or outcome variable. We'll say Y is an outcome of X using data set, say example. This is all just made up, but here's an example of how you want to think about what this little tilde means. Just think of it as everything to the right of the tilde. In this case, all your X variables or your data sets are compiled and processed so that to the left of that tilde is going to be your outcome variable. So that's just a sort of a long-winded way to say a tilde just sort of clarifies the process of creating your output. And that's pretty common in the Mosaic environments. And here I'm going to put some spaces here because you'll see a tilde, and then you'll see some other things. You'll either see like a vertical bar, or what is often known as a pipe, or you'll see maybe a plus sign. Right now, we're only seeing vertical bars. And what we're saying is we want to know that the count or proportion of the survival given their class assignments. And the format we have here is, in fact, the counts. And we're using the Titanic data and we're just deciding the margins are equal to true. We can actually, true can also be equal to false. So when something is assigned true, it just means that you're turning it on essentially. So what does this mean? If you run the tally function and you have here's an example of me re-entering the R environment and not actually running the Mosaic library. So here, remember I told you earlier, you have to install your packages the first time, and each subsequent time you can basically load the library into your memory. That's all you have to do now. I'm no longer highlighting the install packages function, and I'll prove to you through illustration that this should work. Well, look at this. Here I'm able to run the tally function without ever having to basically use the install packages function. And you should be able to do this from weeks here on out. Looks like we have another question. I'm not sure what the other person had asked, but okay. In any case, yeah. So someone has asked, they have a function as, you have the tilde symbol. If you have two parameters to use, you'd also like to include the margin in the results. How to control which parameter the margin is on? Yes, margin is equal to true. If you have two parameters, here's something that's relevant, which is the order of your arguments matter. So here, if you do a tally where survived by gender, you do the proportion, and then you do survived gender by survival. These are going to be two slightly different ways of representing the same data. What am I doing wrong here? Let's make sure I can run the first portion, the first command correctly. Okay. Oh, survived, that's why. So this is an example of how R is pretty persnickety. You have to be clear that you're defining the variables as they are defined. I wrote the word survival. What I want to point out here is that that pipe function, what you're conditioning the outcome on, or in this case, survival as a function of gender, or gender as a function of survival, tells us how to emphasize what it is you want as the outcome. So this is a way of reordering the columns if you have two parameters. But let's start off, typically in this case, we might want to be more focused on survival because it has more theoretical importance as an outcome, as a function of long-standing variables or long-standing predictors such as gender or class. So we might not be interested in what your probability of gender is by survival, just because in this case it's more theoretical to think of survival as a function or an outcome of something else. So in the Titanic, when you type in the margins equals true arguments, you're actually basically saying, okay, among gender subgroups, in other words, if we divide our sample into two groups, male and female, what proportion will say yes to survival for if you're female, and what proportion will say that you survived if you're male? So in this case, if you're female, about those 76% of those who survived, or 75% of those who survived were female, and about 20% or 21% of those who survived were male. So that's a way of representing probabilities as something conditional on the variable that we present after the pipe. If we want to look at survival by social class, we set margins equal to true. All we're doing is we're saying, okay, we're going to have three subgroups. We're going to have lower class, middle class, and upper class. And what's the probability of survival given those classes? Well, what we find here is that probability of survival among those in the lower class, what's the probability of survival if you're in the lower class? Well, we give you the proportion right here, it's 0.26. If you're in the middle class, it's 0.44, and in the upper class is 0.64. Now, a probability is another way to say it's a proportion or percentage. So you can say that 64% of those in the upper class survived, as opposed to 44% in the middle class and 26% of those in the lower class survived. So clearly class is relevant to survival, and same with gender. If we want to look at, we want to look at our social class and surviving the Titanic related to each other, that's essentially what we did in this last question right here. You can basically say, yes, yeah, there seems to be a relationship here. I showed that example of data management earlier in the section, how to load this example of a load function. Here is an example of the path file, or what is known as the path file for the scripts, given that you have a PC. The other thing is how to remove a data set from R. And maybe you want to do this. Say for each week's assignments, you want to remove something. Well, that's simple. If you want to use the remove function, we can actually remove the Titanic data sets. So here we have in the upper right-hand corner the Titanic data sets. So we can actually remove this. And I'll show this in this last section right here. You can see that here's the data set right here. I'm going to just run the script. And you'll see that it disappears. No. OK. It's because you want to just type in Titanic. Yes. And I'm going to remove names.titanic. Or names Titanic too. We'll even have the autocomplete here. And here I know you can see that my global environment's empty. So I basically got rid of the data set I wanted to use to analyze my data. Now here's the problem that you result in, which is essentially, well, now you have nothing to analyze. Let's just go back and I'll just upload the file again. You can just, on a Mac computer, you can do Command O. And then you'll go to desktop, and now I'll just go to problem set 1, and I'll upload the data file, and I'll put it back in the global environment. And some other examples I wanted to give for you: how to create a bar graph of counts in R, where I showed you the bar graph function. I showed you the counts or pi function. This is another way to represent the data. So here we showed what's the count of people within lower, middle, and upper class is another way of visualizing it. Often we don't like bar charts in statistics, but here's a great way to do it anyway. I should end on this issue of what a mosaic plot is, because I think it's useful for representing groups of data. So let's take a look at this. A mosaic plot is relatively interesting because it's a great way of representing data that you might actually not have seen, although I think we should include more of these kinds of data. This kind of data representation in the popular media, you often will see this. Well, what does it do? Well, you can think of the area as the combination counts of both social class and survival. So in this way, mosaic plots are preferred by a lot of statisticians because it's a way of representing both the size of both variables. In this case, social class and survival. We can see that the largest group is survival, but you see that the length of each section here is largest for the lower class versus the middle and the upper class. And then, but on the other hand, you can see that survival is the greatest for upper class and least for the lower class. But also, so it gives you sort of a contingency or count of the total prevalence of a particular group, as well as the relative prevalence of each group, contingent on each variable. So a mosaic plot, I think, is relatively useful. So there's the mosaic plot of survival given your social class, and then if you run it by representing social class as a level of survival, you'll see that these are actually kind of two different ways of looking at the same data. It just depends on what it is you want to provide as the first sort of separating or group definition variable. By that, I mean it's simply saying what do you want to put on the x-axis versus the y-axis. Do you want to represent the x-axis as survival given your social class, or do you want to represent it as your social class given survival? Depends on just simply the ordering of the data. But they still represent the same kind of concepts here, right? The largest risk group is being in the lower class and not surviving. That's certainly the largest group in the Titanic data set. But it also gives you an idea of the relative size of other groups that are still relatively large. In fact, the second largest group you could say is probably going to be by area. It's probably going to be the survival group. that is in the upper class. It's probably the second largest group. The smallest group might be equally divided between these other three, say survival in the lower or medium class, or death in the upper class. But the mosaic plot, I just want to emphasize, is a good way of representing two or more variables, and we include that in the R tutorials as well. Are there any other questions regarding the assignments this section, and also essentially uploading the data file? Yep, that's Andre Mikituk. Sorry, Mikituk. Yeah, so Andre, you're correct, absolutely correct. I didn't emphasize this little operator here, which is this upright bar versus the plus. Andre's absolutely correct that the vertical bar is a conditional distribution, whereas the plus sign is an unconditional distribution. What does that mean? Well, what we're saying is conditional on your survival. What is your social class? Whereas what is the joint probability, or what is the unconditional distribution of social class and survival? In this case, order matters, because how you condition on the first variable matters on how you define the second variable. So the vertical bar is more central to your definition. So are there any other questions that you guys might have regarding the, I think, operators? I know this is a lot to take in the first week, but I think it'll get pretty quick. I think you'll get a good handle of this as the weeks go forward. No other questions? Okay, well, thank you for your tolerating the technological snafu. I will put, of course, thank you everyone else for being patient and for sticking around. I'm going to put this up to the course website. You should also see the R tutorials. Please let me know. Some people have, yes, you can condition on a couple variables. Not two or more variables in this first section. What you would look at is you'd look at the linear model function. So you can actually see this in the Student's Guide to R. That's in future weeks, though. That's basically where you do a linear model. This is why we often talk about multiple regression as the workhorse of statistics, because we also are often interested in more than one variable. We often want to look at multiple variables and condition on multiple variables. Well, that's what you do in multiple regression. So we will look at that, but that's, if you want to take a quick look at that, look at this linear model function. If we wanted to condition on, say, a Y outcome, so what's the probability of, say, survival given, and I'll use the tilde command here, x1, variables x1 plus x2, given your data equals example. That's how you would condition on multiple variables. So that's something called multiple regression. Now, that's not required for the course, I have to emphasize, but that's something we are going to focus on in the simple linear regression model. And the multiple regression model, I just want to emphasize, is just an extension of that. So if you want to look at multiple conditional outcomes, that's something to look at. And it is in our course material, but it's all totally optional. But it's really exciting stuff. Okay, any other questions regarding stats and the contents? Otherwise, keep in mind, we are going to post more sections, more tutorials to the course website. I'm going to post these video to the course website, and feel free to email me at fossey@fas.harvard.edu, or give me a ring at 339-224-8817. That's my contact info. Feel free to reach out if you have any other questions. I'm here for you, and we're here to address any concerns. Otherwise, thank you very much, everyone, and thanks for your input. All right. The next section I'll be hosting this week is Thursday. They'll be after you turn in the homework assignments. We're going to review the previous week's homework assignment and some of the concepts in case there are lingering questions. So I sort of think of this Monday section as a sort of looking forward to the material, and then this upcoming Thursday will be other stuff. Yeah, someone had asked, is there a 1 there? Yep, there's a 1 before prefix, etc. So feel free to get in touch, because I know not everyone can make it to section. That's why we have videos. And the last classes point I want to make is that we are going to have more sections. Given the student enrollments, I think it's a little bit higher than expected. We should have more sections, but we had to work that through with the administration. But I think both of the TAs for the class will have more sections, so that'll be good. Yeah, of course, my pleasure. And feel free to reach out and email, and we'll talk again. Thank you guys very much. Okay, have a good week and good luck with your assignment. I hope this helped. Bye-bye. Cheers.